So today we are gonna complete the rest of the topics about connecting internet to your game. So next topic would be setting up a networked billboard to display an internet image. To set up a network billboard that displays an image from the internet, we need to download an image, store it, and then apply it to the billboard object in our scene. So this requires us to use a manager called images manager uh, that works with a helper script, which is the network service, to handle the actual image download. So let's break down each part of the setup. So first step would be setting up the network service for the image download. First, we need to write code in the network service to handle downloading images over the internet. We use a class provided by Unity called Unity Web Request to receive and send data, in this case an image. So let's open the network service. So here we add a link to the image we want to download. In this case, a scenic image hosted on Wikimedia. Uh, and In the network service, we define a method called download image. Yeah. So here, which this will download the image and return it to us as a texture 2D, which is a Unity object type for handling textures and images. And we use Unity web request texture dot get texture URL. So this is the URL, and to create a request to get an image as a texture. And we have a yield return, which tells the method to wait until the download completes, and after the download we use a callback to pass the downloaded texture back so the other part of our code can use it immediately. So basically, this line of code tells Unity we want to get an image from the URL, and the yield, yeah, and the yield, this line returns the code, uh, pauses the code here until the download is complete. And the callback, this uses the callback to pass the downloaded image, which is a texture 2D, back. And the next step would be creating images manager to manage image downloads and storage. So now we can download an image. We need a manager to handle and store it. We'll create images manager as our main management class. So inside the images manager, we create a variable called uh, so inside the images manager, we create a variable called a web image of type texture 2D to hold a downloaded image. And we create a method called get web image. So when this method is called, it checks if web image already has a stored image. So if web image is empty, it initiates a download using the network service and by calling the download image. And if the web image already has an image, it simply returns the stored value without downloading it again. So this setup avoids repeatedly downloading the same image and saves time by reusing the stored image when possible. So web image stores the downloaded image for later use, and the get image method checks if web image is already filled. If it is, it directly uses it. If not, we download the image. And so to make sure images manager can be used anywhere in the code, we add it to the main management script called, which is managers. So here we define again uh, define a static property for images manager. We add a public static images manager, this line, so that images manager can be accessed globally using managers dot images. And in the awake method, we initialize images manager in awake. So when the game starts, images manager will be set up along with any other managers we have, like the weather manager. And so images dot managers dot images makes images manager accessible globally by calling the managers dot images whenever we need it in the game. So basically, the network service handles the actual process of downloading an image from the internet, and the images manager checks if the image is already downloaded and stores it for reuse. And the managers basically makes the images manager accessible throughout the game, allowing any other script to request and display the image. So the next step will display this image on the billboard in the game, and you'll be able to access it by calling the managers dot images dot get web image whenever it's needed. So yeah, how to display images from the internet on a billboard in Unity. So first step would be set up the billboard object in Unity. Create a uh, simple cube in the scene and position it like a billboard. For example, set the position to something visible like 0, 1.5, -5, and resize it to look like a screen. And this cube will serve as a display where we'll load an internet image. And next, we to control when the billboard loads and displays the image, we'll write a script named web loading billboard. So we attach the script, the web loading billboard script, to your billboard object, which is the cube. Yeah. So here we have a operate method. So operate method, this method is called when we want the billboard to load and display the image. It calls get web image from the images manager. uh, Images manager, when which is the manager in charge of downloading and storing images. And in the on web image callback, this method is called after the image has been downloaded. So the downloaded image is received as a texture 2D object and is applied to the billboard's material using the get component render dot material dot main texture. So this line, basically this line sets the texture of the billboard to the downloaded image, making it appear on the billboard. So when you trigger the operate method function, for example by pressing a key, the billboard will display the image. uh, so caching, so if you want, we'll be adding a caching for effective loading. So why caching is, if you want to display the image on multiple billboards, downloading it every time for each billboard is inefficient. Achieving sorry Caching allows us to save the image after the first download, so it can be reused instantly. For that, we'll be updating the images manager. So inside the images manager, we'll adjust the, let's go back. So we'll be adjusting the get web image function to store the image after the first download and reuse it whenever needed. So the web image is the variable that stores the download image. So when Get web image is called. It checks if web image is null, meaning the image hasn't been downloaded yet. So if the web image is null, it starts download from network with network.download image, and once downloaded, web image stores the image and the function sets it back to the billboard. If web image already has an image, the cached image is sent directly to the billboard without re-downloading. For that, the callback function here is created as a lambda function. So this allows images manager to dynamically create the function it needs on the spot, making it flexible for calling different billboards without knowing their specific details beforehand. So to see caching in action, you can try to duplicate the billboard cube in Unity scene, position it somewhere else, and when you trigger the first billboard, the image downloads from the internet and displays. If you walk to the second billboard and trigger it, the image will appear instantly because it's using the cached version. So here basically the web loading billboard script controls when billboard displays an image, calling images manager to download the image, and the images manager manages downloading images and caching them for reuse. And the caching we optimize the caching, which by stores the image after the first download, allowing it to be instantly loading on multiple billboards. So with this setup, the billboards can efficiently load and display an internet image, and the caching features ensures once downloaded, the image can be reused without additional downloads. So this setup provides optimized way to handle image assets from online sources, in Unity. So next topic is posting data to web server in Unity. So uh, to post data to a server in Unity, we need to understand how to get HTTP post request. These requests allows us to send data to a server, which is useful for tasks like saving game data, player progress, or analytics. So here I'll walk through the code and concepts step by step, showing how to make a post request when the player reaches a specific checkpoint in Unity scene. So first step would be setting up a local server, which is optional. So if you don't have a server to send requests to, you can set up a simple local server using XAMPP. So go to this website and download the XAMPP. So this software lets you run a web server locally. So once installed, start the server. You can access it by typing http basically this line. So in the web browser, and inside the ht docs directly, usually located in the XAMPP installation folder, you create a folder called UIA. This will be where you place any server side scripts to handle requests from Unity. And the next step would be creating a checkpoint trigger in Unity. So in Unity, we'll create a simple object in the scene that will act as a checkpoint. So when the player reaches this checkpoint, it will trigger the code to send data to the server. So you'll add a cube to your Unity scene and position it at a location off to one side and scale it to a noticeable size so the players can recognize it and adjust its position. And then set the collider of the cube to be a trigger, so it detects when player enters without blocking movement. You might want to apply a transparent material to the cube so players can see it as a special object. And next step would be coding the post request in Unity. So we need a way to handle the HTTP request, manage the data, and set it when the player reaches the checkpoint. So for that, we'll modify the network service to handle post request. So in our network service script, we'll add a code that enables us to send post request. We'll create a new method called log weather, which we will be used to send data without about the player's progress or the game state to the server. So we add a constant variable called local API uh, that holds URL of the server endpoint where we'll send data. Here we'll use the local server URL with a script located in the UIA folder. Uh, and the The call API is a flexible method that allows us to handle both get and post request. So to send a post request, we'll create a www form object. So this object um, allows us to add fields with data like example name, cloud value, so that will be sent to the server. So if a www form uh, object is present, call API sends a post request. If not, it defaults to the get request. And so this method, the log weather method takes few parameters, which is name. Name is the identifier of the for the checkpoint. Cloud value is the weather condition value, and the callback, it's a function to handle the response. And inside the log weather, we create new form www form and add fields with data values. uh, we call call API with local API URL and the form data and a callback to process the server response. And now we can add a method in weather manager that calls log weather in network service and passes in the relevant data. So this will be triggered when the player reaches the checkpoint. So the weather log weather method, this method's yeah. So the log weather method, this method starts a coroutine that sends weather data to the server. It includes a callback function on logged, uh, on logged to handle the server's response, and on logged callback. So this callback is basically, so this callback simply logs the server's response to Unity's console, so you can verify that the data was successfully received. And finally we create a checkpoint trigger script. uh, so we create a checkpoint trigger script and attach it to the checkpoint object. So when the player enters uh, the trigger, it will log the weather data by calling the log weather in the weather manager. So in the checkpoint trigger script, we define an on trigger enter. When the player enters the checkpoint's trigger area, the log weather method is called in weather manager with the identifier like the checkpoint. And the triggered value ensures the trigger only activates once per checkpoint. So next step would be configuring the checkpoint in Unity. So assign a unique identifier, for example checkpoint 1 in the uh, checkpoint trigger scripts inspector field, and play the game and move the player into the checkpoint's trigger area. You should see a message in the console with the server's response. So if there's no server-side script to handle the data, an error message will appear. However, if you have set up a server script like a simple PHP script at api.php in the UIA folder, it will handle the data and respond. So this setup allows you to send game related data to a server whenever the player reaches a specific point in the game, like a checkpoint. So this is useful for things like saving players progress, recording game events, or collecting analytics on player behavior. So next is so the last topic is logging game data to the server with PHP. So the PHP script which I mentioned earlier, so I've just saved in a Node document, but yeah, but you need to save it in the UIA folder. So this PHP script, which you would name as API.php, is set up on the server to receive data from Unity. So when Unity sends a post request, like when a player reaches a checkpoint, this script receives and processes the data when it then logs it into a text file called data.txt txt. So here the script retrieves three pieces of information sent from Unity: message, cloud value, and a timestamp. So message, this could be any text message you send, like the name of the checkpoint. The cloud value, this might be the cloudiness level in the game, which represents how overcast it is. And the timestamp, this is the exact time the data was logged. So each of these line use post name. So post, this is the name, to retrieve values sent from Unity in the post request. And the $post method allows PHP to grab data sent from a form, or in this case from Unity, and combine. So this line formats all three pieces of data into a single line of text. Uh, dot is used to combine, which is concatenate strings in PHP. So we are creating a line that might look like this, and does the slash n at the end adds a new line. So each entry will start on a new line in the data.txt txt. So the file name, this simply tells PHP to write the data into a file named data.txt. So this file should be in the same directory as api.php. If it doesn't already exist, PHP will create it. And what else? So the file put contents is a PHP function that writes data to a file. So the first parameter, file name, is the name of the file, and the second parameter, combined, is the string of the data we want to save, and the third parameter, the file append lock ex, has two options: the file append and lock ex. So the file append means that each new entry is added to the end of the file instead of overwriting it, and lock ex prevents other scripts from writing to the file at the same time, avoiding data conflicts. And echo sends a response back to Unity. In this case, it simply sends the word logged. When Unity gets this response, it knows the data was successfully saved. And so how to use this script: you save the script as api.php, place the api.php in your web servers directory, for example in htdocs if you're using xampp, and create a data.txt file in the same directory as api.php. create an empty text file named data.txt. This file will store each log entry, and when Unity triggers a checkpoint, it sends data to api.php, which then logs this data in the data.txt. And last thing would be open the data.txt to see the log data after each checkpoint is triggered, and each line will contain the checkpoint message, cloudiness, and timestamp. So why use PHP for logging? PHP is widely used for handling server requests and is compatible with most web servers. So this script, the PHP script, demonstrates a simple way to save data sent from Unity, making it useful for analytics, players' progress tracking, and other game metrics. So this setup allows Unity to log data to a server, making it ideal for recording in-game events or conditions like weather or player progress for further analysis or player feedback. So that's the end of the topic. Thank you.